Okay, now let's actually get into some real math, right? So take a breather, take a breath if you need to, and we will get into section 1-1. So starting with section 1-1, we're going to talk about functions. So what is a function? In general, a function is a rule that assigns each input exactly one output, okay? So an input is X and an output is Y. So for every value of X, I only get one value of Y. The inputs are called our domain. So our domain are possible X values, and our outputs are called the range. So the range is all of the possible Y values. We can define a function as just simply listing ordered pairs, providing a table. Most commonly, we'll see an equation. We can also look at as a graph, and sometimes you'll even get one as a verbal description. So let's look at this. For example, we have a function relating the degrees Celsius to degrees Fahrenheit. So here, negative 20 degrees Celsius is equal to negative 4 degrees Fahrenheit. 0 degrees Celsius is equal to 32 degrees Fahrenheit. Our domain here would just be the set of negative 20, negative 10, negative 5, 0, 25, 50, and 100. If we're just given table values, the domain is simply a list of all possible X values. Likewise, the range is just a list of all possible Y values. So if you have a table, just list the X's for the domain and list the Y's for the range. This one down here is not a function. And take a minute and see, why do you think it's not a function? Remember that a function has to give, for every input, there can only be one single output, okay? So 0 goes to 5, and 1 goes to 10, and 2 goes to 11, and 3 goes to 25, and 2 goes to 18, and 2 goes to 15, and 5 goes to 30. Here, 2 is going to 3 different numbers. So the same X, which is 2, is being mapped to 11, to 18, and to 15. That makes it not a function. A single X can only go to a single Y. A scatter plot is something we'll see a lot of in this class also. And a scatter plot simply graphs each ordered pair as a point. So our earlier examples where we had those tables back here look like this on a scatter plot. You can see a point for each X, Y coordinate. Now let's think about this. A function or not a function? The average price of gas in Greenville County in terms of date. What do you guys think? Well, I would say it is a function because for each day, there's only one single average, right? Today's average may be $2.85. We can't have multiple averages in a single day, at least not the way that this is defined. Now, what about the name of the pet admitted to the ER in terms of the date? What do you think there? This is not a function because on a given date, we could have multiple names of pets admitted to the ER. In fact, I'm sure most days have more than one pet that are admitted to the ER, right? So today's date or tomorrow's date or whenever's date, one date, so one X value is going to be associated with multiple names of the pets. What about this? Y equals X squared minus 4. We can input a single X value and it's going to give us that single Y value. No matter what we put in for X, it's only going to give us one Y each time. So yes, it is a function. And what about this? Y squared equals X plus 6. Well, to solve this, we really need to take the square root of both sides, right? But remember, when we take the square root, that we end up with really a plus or minus. So for one single x, so let's say x equals 0, 0 plus 6 equals y squared. Well, the square root of 6 squared is going to give us 6, but so will the square root or the negative square root of 6, right? The negative square root of 6 times the negative square root of 6 will still give us a positive 6. So there are two possible y values. Anytime you see y squared, you need to be careful, because if you see that y squared, it typically means that you can have the positive or the negative in the case, and that is not going to give us a function. Now, that's simple enough to think about in those cases, but sometimes we don't want to think about it mathematically, or sometimes we're just given a graph. And lucky for us, there's one really easy way without even thinking through it the way that we just did. If we know the function, we can look at the graph. So if a graph represents a function, it will pass what is called the vertical line test. The vertical line test means that if you put a straight vertical line anywhere on this graph, it will only intersect the graph once. If it cuts across it more than once, it is not a function. So on that first one, we can put a vertical line anywhere we want, and it only touches once, right? It only cuts through it once. On the second one, however, if we put a vertical line across it, in most places, it's going to touch it twice. Look at that y-axis. It touches somewhere right under 2 and somewhere right before -2. That touches that graph in two places. You can do that vertical line anywhere you want along that x-axis once that graph is there, and it's going to touch it twice. That means we do not have a function. In the third one, we do have a function. We can draw that straight up and down line wherever we want, and it's only going to hit it once. Now, most of you should have seen this before in a prior math class, but it comes in handy a lot during our class, so this is a great place to mention. Interval notation is just a mathematical way that we write a lot of things, okay? Two numbers are separated by a comma. The left endpoint is your first number, and the right endpoint is the second number. If you have a parenthesis, so that curved bracket, it means the endpoint is excluded. Okay, so it means everything up to that point, but not quite including that point. A bracket, so the square brackets, mean that the endpoint is included. So it means everything up to that endpoint and including that endpoint. Okay, so if we're talking about an endpoint of 3, an upper endpoint of 3, and we had a parenthesis, that would mean that it was, 2.99, 2.99999, all the way up to 2.99999 forever, but does not include 3. Okay, so it stops at 2.99 infinitely many times. Once it hits 3.0, it's not included in that interval, okay? A bracket with a 3 as the upper endpoint would mean that it goes up to exactly 3.0, with 3.0 being included. Anything bigger than that would not be included. If you're writing an infinity, it will always be an open parenthesis, okay? So let's look at a couple of examples, okay? Square bracket of 3 to 6 with an open parenthesis. That would mean that we are looking at anything between x. Let's take you over here to paint. Sorry, guys, I'll hopefully get more organized with this. Okay, let's look over here. So if we have 3, 6, like that, that means that we are including everything. That means that x is between 3 and 6. But this square bracket here tells us that 3 is included. Okay, it's a square bracket that matters. When we have this open bracket, it means that we have this open sign on the 6. Okay. Now let's say that we want to have 1 less than or equal to x less than or equal to 4. So when we see that, we can go ahead and write our endpoints 1 and 4. We just need to know what signs we're going to be putting there. Okay. Since we have that less than or equal to on both of them, we have a square bracket. Okay. Now, on the next one, we have 4 is less than x is less than or equal to 8. So again, we can write 4, 8, and we just need to decide on the signs. Okay. 4 has no equals to, so it has to be a soft bracket. Okay. 8 has the less than or equal to, so it will have the hard square bracket. And lastly, we have x is less than or equal to 6, -6. X is greater than or equal to -6. My goodness. And that means that we have anything from -6 or bigger included. Okay. So x is greater than or equal to -6. So we're going to go from -6 up to anything bigger than that. So it's going to go all the way up to infinity. Okay. The -6 is included. So we include that hard bracket there. But remember that anytime we have infinity, we want to make sure that we use a soft bracket. So that would be interval notation for that case. Okay, so we can talk about domain and range with interval notation. Okay. Something really important to note here is that when you have this open hole, like you see here at -2, -1, then that means it is not included in that endpoint. Okay. So that means when you see an open hole, that means that you have a parentheses, not a square bracket. So here we start at -2 for our domain, and it goes on forever. So we would have -2 up to infinity. On this one, it looks like there's no restriction on the domain, right? On the domain, it goes all the way from -infinity to +infinity. Both of those will be parentheses, not square brackets. Now on this one for our domain, we see that -1 has an open point. So for our domain, -1 will have a parenthesis bracket, not a square bracket. And it stops when x equals 2. But that is a closed point. So closed point means it's included. And so it will be -1 up to 2. Now, back to functions. Instead of simply saying y equals something, a lot of times we'll use something called function notation, which means that we are using f of something to represent a function. So if we have a function f with an input x, we would use f of x to define the output of the function at x. Guys, this is just another way to say y equals, okay? What does y equal when x is a certain value? That is all that you are doing here. If we have a certain number, then we can solve for f of a by plugging a into the function. will make this make a little more sense here. So first we want to verify that this is a function, okay? We want to verify that it's a function, so we need to say, okay, for every x, there is only one output. If we look, we see that our domain is -9, -7, 0, 2, and 5. Nowhere on here is an x repeated, so we're good. No single x is going to multiple y, so it is a function. Now, if we want to find f of -7, that means that we need to know what is that function value when x is -7. Well, look at the table. Where is x equal to -7? It's in that second column. When x is -7, y is 3. So f of -7 has to equal 3. Now let's do one without a table. Let's let f of x equal x cubed. This is a function because no matter what x we put into there, we only get one y output. If we want to find f of 2, then we simply plug 2 in where x is. So f of 2 would be 2 cubed, which is going to give us 8. F of -1 would be -1 cubed, which comes out to also be -1. Closely related to functions are mathematical models. A mathematical model is a description of a relationship between two or more variables. You need to make sure you define your variable and the units, and it should include the function or equation for the relation. In our class, or at least at this point in our class, you should imagine that almost all of this is going to be a function, right? So if you were going to say that, let's see, the number of quarters you get per dollar are 4. So Q equals 4D, where Q is number of quarters, D is number of dollars. Then that would explain your model right there. You've told it the units and you've told it the relationship. Models might be exact, such as degrees Celsius to degrees Fahrenheit, because we have that exact relationship. Same with that quarters example I just gave. It will give the exact answer every time. Or what we'll see a lot in our class is approximate. We have this data and we want to know what approximately would be the output. What approximately fits this data best. So, for example here, P equals 3.09 times 1.013 to the T, where P is the population of South Carolina in millions, and T is the number of years after 1980. So let's go back to the whiteboard here. And let's take a look. So we know that P equals 3.09 times 1.013 to the T. Now remember that T is the number of years after 1980. According to the model, what is the population of South Carolina this year? So this year is 2021. We can't just plug 2021 in here. We need to know how many years after 2020 or after 1980 is 2021. So we say 2021 minus 1980, and that tells us that it is 41 years, okay? So what we want to do is plug 41 in where T is. So 3.09 times 1.013 to the 41. If we want to solve this with a calculator, we can open our trusty calculator. And we will simply type in 3.09 times 1.013 to the 41. This emulator is just enough different than the real thing that it messes things like parentheses up. This is a great example of when you need to be real careful with parentheses in the calculator. Remember the order of operations and remember to be careful with your order of operations. When we press enter, it tells us the population should be 5.247 roughly. Okay. So if we're talking about 5.427, that means 5.427 million is the estimated according to this model. So you can see that we're doing the same thing that we did with functions. We're just kind of expanding it to a real life situation where we find f of x for a certain x. Okay, so that beautifully sets us up for the next section, which is graphs of functions. Take a break, get some water, do whatever you need, because now we're going to dive into this section. Okay, so given a function, you can plot its graph by plugging several x values into the function, getting the y values, and plotting each point. If you're dealing with a function, you can connect those points with a line or a curve, and you will get your complete graph. This is called the point plotting method. It's something you have probably used before. It's just a nice fancy new name. You'll see that throughout our class, things that sound like they should be complicated, but really you've done them before. So, for example, we want to graph the function y equals x squared plus 1 by plugging in the integer values of x between 0 and 3. So we plug x equals 0, 1, 2, and 3 into that, and we get the output of 1, 2, 5, and 10. So notice that f of x is simply just the value of x plugged into that y equals, okay? Now we can graph this here. We graph a point. So we graphed 0, 1. We graphed 1, 2. We graphed 2, 5. And we graphed 3, 10. And we connected everything with a nice curved line. And that is our function. Now be careful though. Consider our earlier example. Remember that our function was x squared plus 1. And we only looked at 0, 1, 2, and 3. Does that tell us the whole picture? We can't be sure. Let's try it again from -3 to 3 with the integers. Now we get this table. You can easily find that if you plug x in to the same function, these are your outputs for f of x. We do the same graphing procedure and we get this graph. Notice that this graph is very different looking. We only had half of it in that earlier version, right? So that was a problem. We didn't get the complete graph, and that is something we need to look out for. So like we just saw, we have to be careful to include enough points to get a good enough view of the function. I always love math. I especially love statistics, but they do it in this class too, where they say something is sufficiently large or sufficiently good or whatever. How good is good enough? It's hard for us to tell. In this class, we want to make sure that when we're looking at graphs that we want to see the full basic shape of the graph, okay? If the tails are going off to infinity or negative infinity, then we've done our job. We know what that graph is doing. We also want to make sure that we show all x-intercepts and all y-intercepts. So anywhere those points hit the x or anywhere they hit the y. And we also want to be sure that we include all turning points. So where that graph goes from going upwards to going downwards. So if we have a roller coaster of a function, we want to make sure that we have all of those ups and downs included. If you meet these requirements, you have something that is called a complete graph. You want to make sure that all of your graphs are complete in this class. Sometimes you need additional information to know if it's good enough, and our text will usually do a pretty good job of telling you, unless it's something that we have already learned. So let's look at an example. We want to graph f of x equals x cubed minus x plus 1. We know that the graph has no more than 2 turning points. So it goes from up to down or down to up no more than twice. If we use integers from x equals -2 to +2, do we get a complete graph? So we can set it up with the point plotting method, and this is what we get. Now, by plotting those points, if we take a look, we see that the graph goes from going upwards to decreasing, back to increasing. So it has 2 separate turning points. One somewhere around, I don't know, -0.75, and the other somewhere around, I don't know, maybe 0.75, maybe 0.6. It's hard to tell, okay? But you can see that it goes from increasing to decreasing and to increasing again. So that is going to give us a complete graph. We see all of the intercepts somewhere around 1.2, 1.3 maybe, as an x-intercept. That's the only x-intercept. And then the y-intercept around, or right at, y equals 1. Those are all of our intercepts, and we see the turnings. We're good. Now in this example, we're going to graph f of x equals x plus 1 quantity squared minus x. And we want to use the integers between x equals 0 and x equals 2. We know that that graph has only 1 turning point. So here's our table, if we plug those values in, and here's what we get. It's not a bad graph, but the whole thing is increasing. So we don't ever get to see a turning point. That is a problem. This is not a complete graph. Now, we know there's that 1 turning point and we didn't see one before. So now we just expand to include integers all the way from -2 to 2, and we get a better idea of what's going on. This is a much better looking graph. You see the general shape. We see the intercept at y equals 1. There's no x-intercept here. And we see that turning point that's mentioned. We're good. Now, graphing by hand is really nice and simple and quick if you're just getting a quick sketch, but it can really be tedious. Especially, this is 2021, guys. And who's graphing by hand? Not that many people, right? Not unless you're doing a real quick problem. Remember that you have a TI-83 or a TI-84 for this class. It is required and it will be used almost, if not exactly, every time that we talk. The formal steps for graphing with a calculator are listed in your text, but we can talk about a few of the key features of it. First, you want to be sure that you enter your equation. I'm going to talk through all these steps, and then we're going to do an example interactively, and we'll put it all together, and you can see it in action. So everything our calculator does for graphing will be in terms of y, okay? If your equation is not given as y equals or f of x equals or whatever your function is equals, you will first need to use algebra to solve for y or to solve for whatever function, okay? So in that case earlier, in an earlier slide where we said y squared equals something, you would need to solve for just y. You cannot adjust the y in that side of the equation. So in the TI-83, 84, the first thing we need to do is press the y equals button. Once your function is there, you can press the graph button. Again, I'll show you an example here in a second. There's also this nice feature called the window feature. By default, it's going to show you x values from -10 to 10 and y values from -10 to 10. This could certainly cut off your graph, okay? Luckily, the window function gives us a really fast way to adjust this. You can press window and you can adjust your X-min and X-max to be your whole X-axis where you want to see. And you do the same thing for Y-min and Y-max. Some important notation for your textbook. When it gives the notation in square brackets X-min, X-max by Y-min, Y-max, that's what it's wanting you to do, is change that window. Okay, so it gives that to you in bracket by bracket. When you press graph, you'll return to the graph. There's also a button for zoom. There are a lot of fun features with zoom. A lot of people have different preferences to use it. Go ahead and play around, absolutely. But I'll share my favorites with you. First, Z standard. So let's say you messed around with your windows on another function and now you're doing another homework problem and everything's all wacky again. You could go into window and fix it for sure. But if you just go into zoom and select Z standard, it's going to put it back to that -10 to 10. I also like Z box because it lets you construct a little box around your area of interest and you can change the window to show only that area if you need to. I'll show that to you as well. Trace, if we hit trace, it'll allow us to scroll along the function, okay? So it just goes different values. It just scrolls right along that function, writing that whole curve the whole way. Big benefit to trace is at the bottom of that screen, it's going to show you X and Y values, which is really, really helpful, especially if we zoom in and things like that. As we go through our course, you'll use trace quite a lot. You can also use the table button once that function is in. Instead of showing you a graph, it's going to show you a table of X and Y values. Now, if this is the first time using your calculator for something like this, you'll need to go into table settings and you want to change it to ask for your independent variable. Otherwise, it just gives you a bunch of default points that may or may not be helpful. By changing this setting, it allows you to say, okay, well, when X equals 8, what does Y equal? And it'll output it automatically. Now notice this could be really helpful for what we talked about even in the last section. Even if you're not dealing with the graph, it can be really helpful to have it solve that problem for you without inputting it all over and over and over again. Tell it the function and ask it to solve for different values given X. Let's look at an example now. We're going to graph the function f of x equals x cubed plus 3x squared minus 2x plus 5. That's a lot of work, right? So we're going to enter it into the calculator. We're going to look at it as what it gives us right away. We're going to play with the window. We're going to play with trace. We're going to explore zoom. And we're going to find f of 8. So make sure you guys can see this. We can go into our calculator here. And we want to press this y equals button right there. And our y equals x cubed plus 3x squared minus 2x plus 5. Now we can press enter. And when you go to graph, it will show you the graph. Now I do not think, there we go. Now I'm in the standard zoom window. I had zoomed in on a previous problem. Remember I said if you're playing around with other functions, it holds on to that zoom window. So it's always a good idea to get a zoom standard when you start out. So we look here. What do we think? Do you think you see a complete graph? I see intercepts, but I also see the graph kind of go up into space, and then I see it kind of drop down. I don't ever see what actually happens there. So let's try changing the window, okay? We're okay on the X, I think, but we need to go taller on the Y. Let's press the window button. Our X-min and our X-max, I think, are okay. Our X's are fine. It's the Y that needs to go up. So we can scroll down to the Y. We can leave the minimum alone if you want. But let's make the Y max to be 25. Okay? And we'll press enter. And when we do that, we need to go back to graph and let it do it again. And look at that. We see the full graph. We see 2 turning points. We see an intercept here on the y-axis. We see 1 intercept on the x-axis. And we see the full shape of the graph. So changing the window is a nice way to get a better picture of that graph. Now let's explore trace. Okay, trace is this button over here near graph. When we press trace, it's going to put a fun little cursor right on the graph. And if you look at the bottom, it says, hey, x equals 0 right here and y equals 5 right here. So our point is 0, 5. We can use the arrows over and it'll follow that function up and down as it goes anywhere along the function. Okay? It doesn't have an easily explained rhyme or reason as to how far it goes which way. But every point that you hit is going to tell you what x is and what y is. So that's really helpful. Now, I've already shown you zoom standard. If we do zoom standard, it's going to take us back to that graph that we don't really like. But let's say that we want to know more about that x-intercept, okay? We can do something called the zoom box. When you go into zoom and press 1, it's going to put this little cursor, if you can see it blinking. And what you want to do is go to the left. You can go up and down. I like to go a little bit to the upper left and press enter. And then you go over to the length that you want and press enter. Oh. Of course. So we're going to go all the way over. Press enter. Don't press enter when you go back over. That's where I went wrong. Scroll over and scroll down and see it drew a little box. And when you press enter again, it will make your viewing window just that teeny tiny little box that you drew. Now, the great part about this is that now you can hit trace and you get a better idea. You may have to scroll over some, right? And you can get a better idea of exactly what that value is. You could continue to zoom in and zoom in and zoom in if you wanted. We'll learn other ways later in the class to tell us exactly what that value is without wasting too much time with trace. But that is one way to get a better look. Okay. Now, we can also press table. And table is the graph button, but it's the second version of it. So we hit second and we hit graph, so it goes to the table. And if this is your first time using this, make sure that before you go here, you go to second window, which is the table settings. And you want to be sure that this independent right here, instead of being auto, is highlighted on ask, okay? and just press enter to highlight ask, and you're good to go. Then when you go to the table, it should look something like this. It might look different if you already had values in there. But the important thing is that now you can input values of x. So if you wanted to find f of 8, you'd say, okay, well, what is x when x equals 8? What is y when x equals 8? So you say x equals 8, enter, and it's going to do all that work for you. Okay? If you had plugged it in to that same thing, you would have gotten the same answer. Okay? But that saves us a lot of work. You can find f of 10. You could find f of -7. And it'll give us those answers right there. You could find f of 0. We already knew that was 0, 5 because that was the intercept. Okay? You could get all these same answers by plugging it in, that value of x cubed plus 3 times that value of x squared minus 2 times that x plus 5, and it'll give you these same mathematical numbers. But this is a lot faster and a lot less prone to mistakes as long as you've entered all your numbers correctly. Okay, now let's talk about one more thing in the graphs, and that is graphing scatter plots. So sometimes we don't know y equals something or f of x equals something. Sometimes instead we're just given a big table of values like we were talking about earlier, and we just want to graph those points. So we're going to follow these steps. We're going to press the stat button and we're going to choose edit. We want to make sure that the columns we want to use are clear, and I'll show you how to do that. But basically you can scroll up to the header, press clear, press enter, and it'll clear anything you have there. You should enter your data into L1 and L2, okay? L1 needs to be all your x values, and L2 needs to be the associated y values. Then you can go to stat plot, just second and the y button, and you need to press enter to get into plot 1. You've got to turn that plot on, okay? If you don't turn it on, it won't show you any dots. You can put them there all day, but it won't put them on the graph. Now, just as a side note here, you'll need to go turn that off if you're doing a later problem, okay? Because if you're doing a problem with the function, it'll just leave those dots on there. So you go to the same place, you just turn it off when you're done with that problem. Now, there's one more cool function about zoom, is if you go to the zoom button when you're on that graph and select zoom stat, which is at the bottom, it will select a window that's just all of your points. So instead of playing around with zooming in and zooming out and changing your window, it'll do that for you if you press zoom stat. It'll just make sure it includes all of those lists. So let's look for an example here. Let's graph a scatter plot of this data, but we want to let x be the number of years after 1990. So we need to be careful there. We're not entering 1990, we're entering the number of years after 1990. So we're going to go into we're going to go first into stat, and we are going to press edit, okay? And it's going to bring this up. Let's say that you had numbers in here already. No big deal. Just make sure that you scroll up until that L1 is highlighted. When that L1 is highlighted, you're going to press clear and press enter, and it'll clear that out for you. And you can do that with any column you need to do. So our data, remember that we're starting at year 1990, okay? And we're talking about years after 1990. So 1990 is actually year 0 for our data. And then it goes up every 5 years from there, all the way to 2015. That got really big really fast. So we go all over to 25 because 2015 is 25 years after 1990. Now we scroll over and we want to enter our sales. So 1.52, 1.65, 1.89, 1.92, 2.62, and 3.8. Make sure you press enter at the end of your last one because otherwise it will not input it. So there are our points in the table. And we go to second, where we want stat plot. So second y equals. And it's going to show us all of these plots, okay? You're only working with one at a time, so you can press plot off, the plot one, and it should probably be off already. But you want to turn it on. So when you highlight that, press enter to turn it on. And then once it's on, you can go to the graph. So just press graph. Now, notice something here. One, the window is what it is, okay? Remember that the window was adjusted based on our zoom box earlier. So we can go back and put it on standard zoom and get a better look. But also we notice that our function is still there. Remember I said that the graph, the spots and the functions will both graph if you don't turn one or the other off. So we can get rid of that just by going into y equals, hitting clear, and going back to the graph. Now we don't see all of our points here, not easily at least, right? So if we go into zoom, and we have to scroll way down for this one. And option 9 is zoom stat. So yes, zoom stat. And there you go. It adjusted our window automatically. Okay. And that's how we plot a scatter plot. Voila. Now, if you wanted to follow along these, the same things apply. You can still use zoom. You can still use window. You can actually still use trace. If you use trace and go left and right, it'll just bounce you between the points. And it'll tell you exactly what those values are. Okay. So hopefully you don't have too many unanswered questions, then you're able to make sense of this as you go. But note that this is just the start of functions. We will work with functions for most of the semester. You'll be very, very intimately familiar with functions here real soon. If you have any lingering questions after you read the text and you've given it some good effort to understand from our course materials, remember that you're always welcome to send me an email. You can stop by during office hours. We can Zoom during office hours, or you can seek help Math Center. Please do not let yourself fall behind. Remember, there are lots of other resources in our course Blackboard, things that you can poke around and explore, and you'll really, I think, enjoy those, okay? I will make sure there is a departmental document, and there are some other videos embedded by other instructors and other professors that, sometimes those are great and useful. I always encourage my students to make sure that they, use everything that's at their fingertips. Start with my materials, okay? That's what you're going to be tested on, the way that I teach and the way that I present things. But if you need more practice, or maybe you need someone else to understand or to help you understand, sometimes it just takes that right sentence that makes things click. And I fully understand that. If you're not able to stop by and see me, or maybe you like to, go looking through all of those other resources, certainly use the textbook resources, certainly use departmental resources. It will not hurt my feelings at all. But I want you to know that I am here, and I am here to help you succeed.